Hello everyone, welcome back to the Mastering C++ STL series. My name is Puneet Kansal. We are covering the complete C++ STL in this series. So this series will go for 2 weeks, this week and next week. And this is the third session in this series. This is the third session. This is not a standalone session. If you are new here, let me tell you, this is not the standalone session. This is the third lecture in this series. Okay. And if you want to check out this complete series, then you can go to the description and you can register for this complete series, this complete course actually. Okay. And you will also get certificate if you are completing this series. Okay. But don't need to worry. Okay. Don't need to worry. If for this particular lecture, for every particular lecture, you do not require any prerequisite. Okay. So I have designed each and every lecture such as that you do not require any prerequisite. Okay, you do not require any prerequisite. Just you need to know basics of the programming language, like if else, for loop, functions. Basics you need to know, and you can take any lecture individually also. Okay, so if you are new here, don't need to worry. Just take this lecture, consume this, and we will learn, okay, in this lecture how to declare the stack, how to use the inbuilt stack and queue, how to use the inbuilt stack and queue in the C++ STL. Fine. Okay. Before moving on, okay, please let me know if I'm properly audible or not. Hello, hi Mandeep. Hello, hi Divya. Nice to see you back, you people. Okay. Please confirm me if I'm properly audible or not and screen is properly visible. Please confirm me. And meanwhile, okay, let me give you a two-step process to be get placed in MAANG company or any other product-based company. Two-step process I'm telling you right now. So first step is you need to be good at particular language. You need to take a language, either any language you can pick up, C++, Java, Python, whatever language you like, whatever language you like, just pick that language. And after selecting one language, after mastering that language, then you can master. Second step is master the DSA. Solve the problem from a DSA, from all the topics, practice the problem, and then that's it. This is the process to get to the product-based companies. Okay. So first step we are completing already here. First step, that is we are mastering the C++ STL in this series. Okay. And you can register for this series. You can go to the description and you can register for this series. Fine. Fine. Okay. And this is the first step. This is the first step to go to the product-based company. What is the second step? After mastering a particular language, what you need to do? You need to master the DSA, which will definitely be the first, second, or maybe third also round of any product-based company. Okay. So for the second step, first step we are completing in this series. For the second step, okay, what you can do is, let me show you. Okay, from where you can complete the second step. You just go to the iNeuron website. You just let me open the browser. Let me show you. Okay, you need to go to the iNeuron.ai website. After going to this website, you can go to the courses. In the boot camp, you can find out the DSA option over there. And in DSA, you can register for this mastering DSA basic to advanced course. So this is the second step. Okay, this is the second step. This course you can register for. You can find out the complete detail about this course over here on this page. And this is a 4-month course actually. And in this course, I will take this course actually. This is the 4-month course. And every day, from beginning till the end, every day we will practice. Every day we need to do everyday practice actually. Then only the things will change actually. Okay, there is no magic like, okay, you will get to the product based company just by doing some small course or something like that. No, consistency is required. So every day you will solve the problem in this till 4 months, and 100% that will make the impact. 100% that will make the impact. So you can, second step, you can register for this course. We are covering all the important topics. All the important topic you can check out till the dynamic programming we are covering in this course. Okay, all the important topic you can check out in this. So let me show you. So you can see all the important topics are here. Oh, complete DSA we are covering till the advanced one. So you can register for this course, and you will, one thing I can tell you, you will not regret. You will not regret that, okay, why you register for this course, because you will find out the difference in you. Even while the course itself, you can find the progress, how much progress you are making. This is the only difference. Means if you are going through a course or you are going through competitive programming. In competitive programming, that is the best way, but you don't know, okay, how much progress you have made, and maximum people give up over there. So second approach remains, okay, if you take some course and then you practice every day. So this is the 4-month course. We will practice every day in this course, and you can register for this course. And if you will follow me, I can give you guarantee nobody can stop you. Nobody can stop you to go to the product-based company, because there is no reason left. Because there is no reason left to not go to the product-based company. Hello Vishal, nice to see you back. Okay, fine. So, okay, let's start with today's session now. Let's start with today's session. I'm going to back to my PPT. Today we will discuss the stack and queue in C++ STL. Fine, do not need to know anything, no prerequisite. Just come and enjoy and you can go. Okay. Just you need to reply. Okay, that is the prerequisite. You need to I will ask the questions, you need to think, and you need to reply. That will be the prerequisite. It's not going to be one-sided. If that will be one-sided, then that will not benefit you that much. That will not benefit you. So if you really want to take the benefit of these classes, you need to be reply. Right or wrong doesn't matter. That should not matter in class, because we are learning. We are learning. So mistakes will happen. It's okay. Fine. Okay. Now let me move on. Let me move on, and let me share with you people the complete syllabus for this series. Complete syllabus for this series. Let me show you. So this is a complete syllabus for this series. We have already covered introduction to C++ STL and templates and iterators. Iterators are important. And this was covered in the first lecture. This is covered in the second lecture. And today we are covering this in the third lecture, stack and queue. After that, okay, we will cover this, DQ, priority queue, forward list, list. These are singly linked list and doubly linked list actually, which are inbuilt in C++ STL. This is very powerful tool, unordered set and multi-sets. Very powerful tool, unordered map and multi-map. And there are many inbuilt algorithms like sorting, binary search, and all that. Different algorithms are available here. We will discuss all of these important algorithms. And after this series, you will be very comfortable with the C++ STL, because we are covering all the functions. All the functions we are covering over here. Practice also we are doing over here. If you are replying your practice, you are doing practice also. You can make notes so that you do not forget the things. That is the thing you can add in this. And we are also solving product-based company problems. So today also, we will solve the problem from MAANG companies related to stack and queue. After covering stack and queue, inbuilt stack and queue from C++ STL, then we will solve the MAANG company problem. Okay, so we are doing practice also, and you can see, okay, how actually you will see that, okay, how actually these inbuilt functions are helping us to solve the problem faster. And this is the way you need to work in product-based company itself. They will not ask you to write the stack program separately. Okay, they will ask you to solve some bigger problem where you are using the stack or Q. So the same thing we will do in this lecture also. So let's start with stack and queue. Let's see how we can declare what are the functions with the stack and queue, and then we will solve some MAANG company problem related to stack and queue. Fine, okay. Divya, you can. Yes, I'm not sure about the discount on the course, but you can check out that. You can check out that thing. You can connect means you can raise a query over here on the website. Also, you can make the query. There will be some option over there, and you will. I hope there will be some discount going on. You can try over there. I'm not sure about that. Already that is actually at the price of 3750, but still you can try. Ramesh is asking, okay, about the little bit about the course. Okay, let me tell you. So if Ramesh is asking in which language you will cover that advanced DSA course, mastering DSA. So one thing is sure, we are covering from basics to advanced. And second thing is that, okay, language you are asking. So I will cover 3 languages: C++, Java, and Python. So every problem I will provide the solution in 3 language: C++, Java, and Python. So from whichever language you are, you will feel comfortable. Don't need to worry, Ramesh. Fine, okay. Let's focus now on today's session, that is stack and queue. Let's start with the stack. Starting with the stack. So we will see, okay, stack in C++ STL. Don't need to worry about this person. I think he is Ajay Devgan, and he's trying to delete the element from the top of the stack. Don't need to worry. So stack actually behave like this only. Stack delete the element or insert the element at the top only. At the top only. So we will use inbuilt stack. We do not need to build our own stack. We will use that stack. We will see its function. We will see how to declare it, and we will use that to solve MAANG company problem in today's class. Fine, okay. So let's see the stack in C++ STL. Let's start with the C++ stack. See, I'm starting with the definition, starting from very basic, starting from the definition. What is a stack? Stack is a container of objects that insert and remove the elements in which manner? Last in, first out, based on the principle of last in, first out. The element which we are inserting last, that will be deleted first. Okay, like you can take the example of plates in the marriage. Their plates are one over the other, and which plate you will take first, that will be on the top. So the plate which is inserted last, you will take that first. So that is an example of stack itself we see. Okay, so stack is about LIFO. That's it. If somebody is saying stack, then LIFO should come to your mind. The last element which you inserted, that should become out first. Last element inserted, that should become out first. That is stack. Okay, fine, okay. So let's check out now some other important things about stack. Stack uses, okay, this is important. This is important. This is important. Stack uses either vectors or DQ. DQ is a double EQ. Okay, double-ended queue. Double means in which we can insert at both the end and delete also both the end. Tomorrow we will cover the DQ in very detail. So right now you can notice that, okay, here in DQ we insert the element from both end, from front and back. We can insert from both end in DQ, and delete also from both end, from front and end. Okay, so stack is implemented on some other data structure. So what other data structure that can be? That can be array, means vector, or that can be DQ. DQ is it's like a queue only, but here you can insert and delete at both end. So that is DQ. So on DQ, with the help of DQ, we are implementing the stack. C++ STL libraries are implemented the stack using DQ, using the DQ as a base container. Okay, these are adapter container actually. This is adapter container. Adapter containers are built up on other containers. These are built up with the help of other containers. Okay, so vectors can be used, DQ can be used, and list can be used. List is a doubly linked list. List is doubly linked list. Doubly linked list. So we can use vectors, we can use DQ, we can use doubly linked list, means list. We can use these as the base container, which are converted to the which are used as a stack, Okay, fine, you can ask me the question from here. If you find difficulty in anything, find difficulty, immediately ask the question. That is important. Otherwise, let me ask one question from you people. Can you please answer this question? So this is Adobe interview question. Can you please try this question? Please reply this question. Meanwhile, I'm taking the question from your end. So there is one message, okay, from backend team. You can take that message also. They are providing, providing some code over here in the live class, and you can avail this offer. This course is available at 1,999 rupees only. So this is given by the backend team. So you can use it. Fine, okay. Okay, you please tell me what is the output. Can you answer this question, please? Important, very important question. Can you answer this question, please? Anything which is coming to your mind. Why DQ is used as base container for implementing the stack in C++ STL? Interview question from Adobe. Can you answer? If you don't understand the question, ask me the question. What you don't understand. Okay, let me repeat what this second point says again. See, stack, queue, these are the adapter containers. Means these containers need to be implemented with the help of other containers. Or I can say that stack, queue data structure need to be implemented using other data structure. Which other data structure? Like stack can be implemented using array. An array can behave like a stack. Okay, you must have read stack array implementation of stack. Or maybe you must have listened linked list implementation of stack. So here, by default, DQ is used by the C++ STL to make the stack DQ, and the Adobe is asking, but why they prefer the DQ? Why these people who write the C++ STL, why they prefer this data structure to build the stack? They're asking this thing. Is there any specific reason? Mandeep is saying, okay, DQ is faster. No, vector is much faster. Vector even more faster than the DQ. Why DQ is used? Okay. So there is something from Divya. Divya is saying that, let me highlight this thing. You need to answer the question. Then only the learning will be better actually. So stack can be implemented using queue. We can implement one data structure by another data structure, but by default DQ may be due to its efficiency and minimum time complexity compared to other. Okay. So let me tell you why we are using DQ. It's very simple. Means this is DQ. This is your DQ. You need to know just how DQ work. In DQ, you can insert the element from the front. You can insert the element from the back also. This is your DQ. You can delete the element from the front. You can delete the element from the front. you can delete. Let me write delete. You can delete the element from the front, and you from the back also you can delete the element. From the back you can delete the element. So insertion, deletion both can be performed at both end actually over here. Okay. In the case of stack, you need to perform, okay, you need to at that from the top. Let's suppose this is, you are making this is as your top. You're making this is as your top. You need to perform both the operation, delete and insert at one end. At one end, you need to perform both the operation. At one end, you need to perform both the operation. These both operations are given by the DQ. DQ is giving both these operations. Okay, so whoever data structure is giving this thing, whoever data structure is providing at one end, if you can perform two operation, insertion and deletion, both you can perform. Actually here we can perform that in order of one time. We can perform that in order of one time. In DQ we can perform insertion and deletion at one end. Both can be performed, and both can be performed in constant time. So that's why actually we are using DQ as a stack, because we need to make it behave it like a stack. And yes, we can perform from the top insertion and deletion, okay, and both can be performed in constant time. Okay, so this thing also can be done with the help of vector. Yes, vector also supporting this thing, so vector can also be used. Even doubly linked list is also supporting this doubly linked list. In doubly linked list also we can perform insertion and deletion at both and in constant time. In constant time, okay. But if you will take singly linked list, then you cannot actually perform deletion in constant time. You cannot perform deletion in constant time. So we cannot use singly linked list. We cannot use singly linked list to implement the stack. We cannot use singly linked list, because deleting the last element will take order of n time in singly linked list. In doubly linked list, if we are using doubly linked list, that will take order of one time. So list is nothing, just a doubly linked list only. So we can use doubly linked list to implement the stack. Fine, okay. Yeah, DQ is also implemented by the other containers. Okay, by the other containers. Yes, DQ is also implemented with the help of other containers. Fine, okay. We will discuss in more detail about the DQ and priority queue tomorrow. Tomorrow we will cover DQ and priority queue. Fine, okay. So DQ can perform both the operation at both the end, and time complexity is also constant. That's why that is used to implement the stack in C++ STL. That's it. That's the reason. Fine, okay. Now let's see the syntax. This is the syntax for the stack, how we declare the stack. So this is a keyword. This is a keyword. This is the data type. What type of data the stack will store. This is the name of the stack name, whatever you can give. For example, this is the keyword. Fine. This is the data type, integer. This stack will store the integer, and name of this stack is S1. Name of this stack is S1. There can be other example like again, this is a keyword, and data type is character now, and name of this stack is S2. So this is how we declare. That's it. This is how we declare the stack. This is the integer stack. This is the character stack. Fine. That's it. This is the syntax of the stack. Fine. Let's see now functions of the stack. Let's see now functions of the stack. So first function is the push function. First function is the push. It's very easy actually. Let's go it faster way little bit. It's very easy. Means this will push the element. This will push add the element G at the top of the stack. So this element will be inserted at the top of the stack. Because this is a stack, so this is confirmed. Because this is a stack, element will be inserted at the top only. Which element? The element which you will provide. The element which you will provide. So this function, these are inbuilt function. These are inbuilt function which are working with this stack class. Okay, and you can insert the element directly by using this function. That's it. Very easy. So this will take constant time to insert the element. This will take constant time to insert the element. Another function is pop function. This will delete the which element from the top also. This will also delete the element from where? From the top only, because this is a stack. So do not need to provide which element, because this will definitely delete the element from the top only. So delete the most recent entered element, or you can say delete the top element from the stack. This will also take constant time. Okay, insertion and deletion at the rear of a DQ take constant time. So yes, inserting, pushing the element and deleting, these two operations will take constant time. So okay, let me maybe I can execute them also. Let me see other function first of all. There is another function, okay, top. Okay, before moving to these two, let me implement these two functions. Okay, let's implement these two functions in a compiler, and we will get the idea. Okay, how actually these functions are working. So I'm going to C++ compiler. You can take any one. I just open it, online compiler, and let me write over here. So what you can do, see, you just can add two header files that will help you. One is include, that will always help you, like bits std c++.h. One is this one. So by adding this header file, actually you do not need to add any other header file. So like for stack, we will be needing stack header file. For Q, we will be needing Q header file. For DQ, we will be needing DQ header file. So rather than adding different header files for faster implementation of the code, we just mention one header file. This include all other header files. Okay, yes, this will little bit slow down your code, but that is not going to impact that much. Your code will be accepted. Your code will be accepted on code forces also, and lead code also. So another thing you need to do is you need to use a namespace std, namespace std. So after declaring this namespace std, you do not need to mention std with cout, cin. So with these functions, you do not need to mention them again. Okay, so you like here with cout, this std is mentioned. So now we can remove it. We don't need it. And if you will run it, so this will print hello world. So we do not need this std type. We can use this namespace. Fine. Okay. Now we are implementing these stack operations. So we know how to declare the stack. So we write the stack keyword. Yes, we write the stack keyword. We write the data type. Okay, let's suppose the data type of the stack is integer, and after that we write the stack name. So let's suppose stack name is S. Yes, we declare the stack. That's it. We declare the stack. Now let's push some elements inside the stack. So s dot push function we need to use. Let me push one element 10. I hope now this is visible. Let me move this side a little bit so that you can visualize it. So we are just covering all the functions of related to stack. First easy one is the push one. We inserted one element, that is 10, inside our stack. Let me insert some more. So let me copy this same statement. So push function is used for inserting the element. So I have inserted now 3 elements, 10, 20, and okay, 30. So we inserted 3 elements from the stack. Okay, Now I'm printing something. I'm printing the top element s dot top. So can you tell me what will be the output? Please reply in the chat box what will be the output for this. Please reply in the chat box what will be the output. Keep replying. Please keep replying. If you will reply, then slowly when we will move on to complicated code, then we will stay connected. Please reply what will be the output. So yes, this will be 30, and you know that because this is a stack. You know that this is a stack. So first 10 will be inserted, then 20 will be inserted, then 30 will be inserted. So 30 is at the top. So this top function, okay, now you know the top function also. Top function is returning the top element. Top function is returning the top element. Okay, let me try to delete the top function, top element. So to delete the top element, what I need to do, just pop. We can use the function pop, s dot pop. So just I write a function s dot pop, and after that, okay, again let's print the top element. Let's print the top element. Okay, now we deleted the top element 30. So we deleted 30 now, and if we will print the next element, now the top is 20. So this will print 20 actually. This will print 20. So let's execute and let's check out. Let's execute. So another function is the top function, which is 20. So next element is 20. So let me make some space over here so that we can visualize it. Let me write endl. So this will come in next line now. Endl is putting a line over here. So 20. Now the top is 20. Earlier the top was 30. Now the top is 20 because we deleted one element. Okay, let me make one modification over here, and you people please tell me what will be the output. Okay, so I'm just taking this top function from here. I have deleted this, and I'm making it. I'm putting it with the C out. I just pop the element and put it with the C out. What is the output? Can you please reply? Will you please reply what will be the output? So I just I pop one element and I C out. I put it with the C out. Can you tell me what is the output? Can you tell me what is the output? Actually, that will not be 30. That will not be 30. This will give an error. This will give an error. Let me run this code. This will give an error. So, okay. Why this is giving us an error? Actually, the reason is that this is important, means pop function do not return anything. Pop function do not return anything. Okay, pop function delete the element. Pop function delete the top element. That will delete the top element, but this will not return this element. This will not return this element. So what if I want to know what is the top element? Then you can use the top function. You can use the top function. So if you want to delete the element and you want to print it, then you need to combine these two statements. You need to combine these two statements. You need to first print the element with the top. Top will access the top element, and then after that, okay, you can delete that just writing s.pop. That's it. Okay, that's it. So these are the two operations you need to perform together. If you want to print also whatever you are deleting, so first print, first if you want to access the element, then top function you need to use. If you want to delete that, pop function do not return anything. That do not return anything. Top function returns. Top function, top function returns, but this do not return. Fine, okay. Now you understand. This is the one misconception remains here. So now that is clear that okay, if we want to see the top element, then we need to use the top. Pop function do not return anything. Yes, that delete the element. Fine, okay. Fine. Let me add some more statement over here now. So I'm writing, okay, C out one another function s dot size. Can you tell me what will be the output now? For this function, can you guess what should be the output? Can you guess, please? Keep replying, please. Divya is asking push function. Push function is inserting the element at the top. This is inserting 10, then 20, then insert 10, 20, 30. Push is inserting the element. Pop is deleting the element. Okay, this is inserting the element. They are not returning anything. They are not returning anything. Okay, you are saying 2. So if we run it, so this will return the size of the stack, and you know that because you have deleted 30, earlier 3 elements were there, you deleted 30, the number of elements is 2. Yes, you know now about the size function also. So let me add some more function over here. So okay, first of all, let me add more element first. So let me copy and paste some elements. Let me add some more elements, 40, 50, 60. Fine. So we inserted 6 element. And we printed the top element and deleted it. And after that, we see the size. Okay. And let me try to print all these elements now. So let me try to print all these elements while s dot my stack is not empty. So there is a function empty. So this empty function will return true if the stack is empty. If stack is empty, this will return true. Otherwise, this will return false. Okay, fine. So I'm checking if this is false, then we will print the elements. Okay, if this is false, then we will print the element whatever is the element inside the stack, we will print. So you know that to print the top element, we can use the top function. So let me print it, and let me make some space also so that you can visualize the difference between the every element. We print the top element, and let me delete also the element. So I'm printing all the element from the stack until my stack is not going to empty, and I'm taking the top element, and let me pop also s dot pop. So okay, fine. This will print all the elements from the stack one by one. Okay, so let me delete this thing. Let's check out this loop only. I'm repeating, this empty function will return true. This empty function will return true if stack is empty. Otherwise, this will return false. So until unless there is element inside the stack, your loop will keep moving on. And you are just printing top element every time and deleting that. Printing top, deleting it. Printing top, deleting it. So this will print the element in reverse order, like 60, 50, 40, 30, 20. Because 60 will be at the top. That is inserted at the end. So let's see how this is working. Yes. This is printing like first 60, then 50, then 40, then 30, then 20, then 10. So now you know how to use this empty function also. How to use this empty function also. Till now, any doubt, please let me know. Could you please explain why return 0? Okay, you are asking why we are returning this 0, because we mention here integer. We are saying that we are returning integer. Okay, by default we return the integer. This is the by default, we return the value in C and C++. In C++, by default we return the integer. You can write void. Here, and now you can remove this statement. Void means you are not returning anything. Now you can remove this return statement. Okay, actually that, okay, this C++ compiler here that have fixed, they have fixed that. Okay, in C language you can do that. Okay, By default, they are assuming that we will return integer. We will return integer. But this is showing that this is just to show that, okay, the main function is working properly. The main function is working properly. That's why they just add this thing. In the C language, actually, we could we could write void, but in C++, okay, they are not allowing us. So we need to return 0 simply because here this is means this is what is inbuilt in the compiler. Compiler is looking for the main function. Compiler want to execute this code, so that is looking for the main function. This is how they have defined the main. They are saying that, okay, you need to return integer 0, which is showing that, okay, your code main is working properly. Main function is reached to the end and working properly. That's why, okay, there is nothing very fancy over here. Do not just we are returning integer. That's it. Okay, fine. Now, okay, we have seen the important functions in stack. So what are the important function? Push, pop, top. That was important. The difference between top and pop. Top and pop, the difference was important. Top is accessing the top element. Pop is deleting the top element but returning nothing. Empty function also you have seen. Okay, these are the important function just. And okay, we can try. What is the size function you have checked out? Size function also we have tried, and empty function we have also tried. Fine, okay. Now let's solve one problem. Let me go back to my PPT and let's solve some problem related to stack. So these are the function actually what we discuss. Push function, pop function, top function return the reference to the top element. This is returning the reference to the top element. You can see here, topmost element. This is also taking constant time. Next one is, next function is size. This is returning the size of the stack. Empty function you have seen, all are taking constant time. You can see all are taking constant time. Empty will return true if stack is empty, otherwise false. So these were the function. That's it. So let's now use the stack, inbuilt stack, to solve one MAANG company problem. Okay, this is the best problem actually to understand that, okay, how we can use the stack, inbuilt stack efficiently. Okay, so we will try to build queue using 2 stacks. We took this problem earlier also in our DSA course. I find out this problem is the one of the best problem, which is taking the inbuilt stack, which is taking inbuilt stack. We don't need to implement our own stack now. We can take the inbuilt stack which we learn right now, and by using the inbuilt stack we can build the queue. We can build the queue. Okay, so let's try to build a queue using the 2 stacks. Okay, let's try to build the queue using the 2 stacks. Any idea? So building the first thing is that building the queue means this functionality, building this functionality. First in, first out. First in, first out. If you can make behave the stack, if behave like this, although the stack behave like what? Stack behave like last in, first out. Stack behave like this, but you are saying that no, stack, you do not behave like this. You please behave like this. You're asking to the stack to behave like this. If stack is behaving like this, then you can say that, okay, you have implemented queue from the stack. Okay, so if stack is start behaving like first in, first out, although the stack behave like this. So by making some modification in the code, by coding something, you can implement the queue using stacks. So any idea coming to your mind how you will use the 2 stacks to implement a queue? You can write in the chat box. Any idea? You can write in the chat box. Otherwise, one example I am taking over here. You please keep helping me. We want to implement the queue. This is our queue. Okay, this is our queue. This is not queue. Okay, fine. So let's suppose we want to insert some element in this. So we insert from the rear. First we inserted 10, then 20, then 30, then 40, then 50. So we inserted 5 element. Okay. They're asking us, you please use 2 stacks. Let's suppose stack 1 and stack 2. Please use two stacks. Make them behave like a queue. Make them behave first in, first out. Okay, means the elements which we are inserting first, that should go out first. Okay, although in stack the element which is inserted last, that will go out first. Okay, fine. So we need to perform 2 operations. One is push, one is pop. These 2 operations we need to perform. That's it. So push is very easy. This is very easy. Very easy. How? So whenever the element is coming, like 10 is coming, just store that into stack 1. Then 20 is coming, then 30, 40, 50. Keep storing them into the stack. Stack 1. Keep storing them into the stack 1. That's it. So whenever the element is coming, no problem is happening. Just simply keep storing them in one of the stacks. So let's suppose we store them into stack 1. That's it. The problem here is that now, if we want to use this stack as a queue, now if we want to delete the element, if we want to pop the element, if we want to delete the element, 10 will be deleted because 10 is inserted first. But right now we cannot delete the 10 because this is a stack, so we can delete 50 only. We cannot delete 10 unless we do not delete 50, 40, 30, 20. So what we can do is, like you Mandeep said, that you can pour the element from this to this. You please take these element and put it inside this. So let me put it 50, take it, insert in here. I want to delete 10. Okay. For that I need to put these element here and then I will get my 10. So taking one by one all the element into stack 2. Taking one by one all the element taking into stack 2. So I took all the element from stack 1 to stack 2. Now I can delete, yes, I can delete 10 because 10 is at the top. This is a stack. In stack, we know that stack behave like last in, first out. So whatever is the last element, we can delete that. Yes, we deleted 10. We deleted 10 now. We deleted 10 now. Fine, okay. Now we want to delete next element 20. So yes, we can delete, that is itself at the top. We want to delete next element 30. Yes, that is at the top. But what will happen if new elements will come? Where you will insert? Please tell me, in stack 1 or stack 2? New element come, let's suppose 60 and 70 new elements come. Where you will insert? In stack 1 or stack 2? Please reply. In stack 1 or stack 2, where you will insert? Just give just whatever is coming to your mind, please share. Or any other question is coming, please share that also. Any question is coming, please share that also. Or any doubt is coming, please share. Or otherwise tell me in which these 2 new elements we will insert. 60 and 70. Stack 1 or stack 2? It's okay, Faizan. You can join from here itself. Okay, let me try to, if I insert 60 and 70 here in stack 2. Stack 2, if I insert 60 and 70. This will create the problem actually if I will store them into stack 2. Why? Now next element which I want to, if I want to delete next element, that should be 40. But what is at the top of this stack? 70. I cannot delete 40 until 70 is at the top. Okay, so this is creating the problem. Storing the new element into stack 2 is creating the problem. Okay, because I cannot delete the 40. So what we can do? We can store them into stack 1. We can store them into stack 1. 60, 70. More elements come, it's okay. More elements come, we can keep storing them in stack 1. We can keep storing them into stack 1. Now again, okay, we want to delete the element. That's what we want to delete. We will delete from here 40. Next element, if we will delete from the queue, that will be 50. Yes, we can delete, that is at the top of stack 2. Next element is 60, we want to delete. But stack 2 is empty. Stack 2 is now empty. All the element is deleted. When stack 2 is empty, what you will do? Same process actually what we have done earlier. Take out all the element from here. 90, 80, 70 and 60. Take out all the element and put back into the stack 2. Okay. And if you want to delete, now you can delete 60. Yes, next element is 60, 70, next element is 70, next element is 80. Yes. So what is the idea? How to solve this problem? Simple idea is that to perform the push operation, that is very easy. Just insert the element into stack 1 only, because if you will insert them into stack 2, that will create the problem, because we will lost our top element. Top element should be whatever we inserted earlier, that should be at the top, because that will be deleted first. So simple idea, when we are inserting, pushing, then that should be inserted into stack 1. And when we are deleting, when we have to delete? How to delete? Keep deleting from stack 2. Keep deleting from stack 2 until unless that goes empty. Until unless that goes empty. If that is empty, then shift the element from here to here. If stack 2 is empty, shift the element from stack 1 to stack 2. That's it. Okay, let me write over the same stuff. Push. If we are performing push function, what we need to do? Simple. Let's suppose X is the element. So in push the element into stack 1. That's it. Finish. This function is finished. That's it. Done. One more function we need to implement, that is pop. Pop means top element we need to delete. Okay. Now you will see that if you will check the condition, stack 2 is empty or not. Stack 2, if you are checking if S2 dot empty, we can use this. See, we can directly use, we are directly using the functions like if stack 2 is empty, so stack 1 and stack 2 are inbuilt stack we will use. So you can declare them like stack 1 and you can declare the stack 2. So now we are using the inbuilt stack 2. After that, you can just apply the functions directly, push function, pop, empty function, pop function. So while performing pop, you will check if the stack 2 is empty. If stack 2 is empty, what you need to do? You need to take the element of stack 1 and put in stack 2. So if I'm checking, okay. So while, okay, I'm writing, while I will take all the element of stack 1 to stack 2, while my stack 1 is not empty. So unless my stack 1 is not empty, what I will do? What we will do? We will take the element from stack 1. So let me take the element from stack 1. Let me take the top element. Top function you know now. Top function you know now. You take the top element from stack 1. Take this element and push it into stack 2. S2 dot push. That's it. Okay, take the top element from stack 1 and push it into stack 2. And you can delete the top of this stack 1. S1 dot pop. That's it. So this loop will transfer all the elements of stack 1 to stack 2. So if stack 2 is empty, you just transfer all the element from stack 1 to stack 2. There may be one condition that you can say that, what if the stack 1 is also empty? You can check one more condition over here. What if S1 dot is also empty? If stack 1 is also empty, stack 2 is empty and stack 1 is also empty, then you can say that there is nothing to delete, nothing to pop. You can return -1. Underflow, you can show underflow. Underflow is shown by -1. So this is the underflow condition. both the stack is empty. S2 is also empty, S1 is also empty, and you are still asking me to delete the element. How I can delete? There is no one. There is no one to delete. How I can delete? Fine. Okay, this is the underflow condition also we write. After doing this, now we need to pop the element. We transfer all the element from S1 to S2. Now you can delete. Okay, I'm writing little bit more code in this further. Now and you need to take, you transfer all the element from, let me transfer over here. So this is your stack 1, this is stack 2. Earlier, let's suppose 10, 20, 30 and 40 was here. So you take all the element one by one and insert it into stack 2. You take all the element one by one and insert it into stack 2. After inserting, now you said you want to pop the elements. So yes, we will delete the pop. So what we can do? We can delete from the top of the S2. So I can store this element which we want to delete into a variable, element variable, maybe any variable you can take from S2 top. So this will take 10 actually. 10 will store in this variable now. This 10 will store in this. Now I can delete S2 dot pop. I can delete this element. After deleting, you can return this. Return this element. That's it. That's it. Done. We're done with this. We're done with the push function. Push is very easy. Simply the element is coming. Insert into the stack 1. Pop, that is also easy. Keep deleting from the stack 2. Keep deleting from stack 2. Keep deleting. But if stack 2 is empty, if stack 2 is empty, then you need to take the element from stack 1 with the help of this loop. Empty the stack 1, take all the element and pour it into stack 2. We're done here. This is the underflow condition. If both the stack is empty, then return -1. After pouring all the element from stack 1 to stack 2, take the top element from stack 2, take the top element and delete it. That's it. This is what they're asking us to delete one element. We delete it. That's it. This is the code for that. Any doubt in this, you can ask me. Any doubt coming, please ask me. Otherwise, okay, let's try to code it. This is the problem I have taken actually from lead code. So I'm going to back to lead code. Here is the problem. Implement a queue. Let me erase everything. You can also try. You can open in your laptop and you can try this problem, like implement a queue using 2 stacks. Actually, we are using 2 stacks. So let me go to the description. So here actually they have mentioned that. So we need to implement it using 2 stacks. 2 stacks. We need to implement actually push function. Push, you know, very easy. Just one statement. Let me write. So we have 2 stacks, S1 and S2. Whenever you need to perform push, insert in stack 1. Let me do it. S1 dot push. Whatever element was there, X. So let me put the X in this. Done. Finish. Push is finished. Done. What about pop? Now pop function is there. We want to delete the top element. So we will delete from the stack 2. But if stack 2 is empty, then we will take all the element from stack 1 and put it into stack 2. Then we will delete. Okay. Any question you can ask me. If stack 1 is not empty, then if stack 1 is, yeah, when you are pushing the element, you do not need to worry stack 1 is empty or not. Faizan, you do not need to worry. Let me highlight the Faizan question. So Faizan, while push operation, you do not need to worry stack 1 is empty or stack 1 is full. You do not need to worry. You just keep inserting the element because that will not make the impact. See, this is your queue. 10, 20, 30. Let's suppose first you inserted these 10, 20, 30. Some more element come, okay, 40, 50. It's okay, insert it here, 40, 50. There was some element over here, that was also fine. Let's suppose these elements are not here, still that is also fine. Because because the sequence you are not changing, the sequence you are not changing. So while push, do not need to worry if the stack 1 is empty or not. If that is empty, then also fine. If that is fill, that is also fine. That is not changing the sequence. Okay, sequence is not changing. So push function, we do not need to worry at all. What about the pop? Divya is asking, okay, another question from Divya. For full, we need to check. Yes. Okay. For push, you do not need to check for the full. Okay. You do not need to check for the full. Actually, if you notice here, they means we cannot. This is inbuilt function in this lead code. And if you notice, they mention void here. We cannot return even -1. Do you understand? We cannot return -1 to show that okay, stack is full. Stack is full. So we do not need to do anything. Overflow condition you do not need to mention. Overflow condition you do not need to mention. So sir, overflow and underflow condition would not come. Faison says that okay, overflow underflow condition will not come. Overflow will not come. Underflow will come. Actually, they have mentioned this thing. If you will check out this problem, they are saying that for the underflow you can mention -1. Okay, we can return -1. You can check out this problem. You can check out this problem. Okay, and for overflow we cannot return anything because they have mentioned void here. But for underflow, okay, they will accept because integer is here. Okay, we will return -1. We can return -1. Fine. Okay, fine, Faison. So let's now try to code this pop function. We have already discussed. Let's do it. Let's first finish it. Then I will take Divya and other questions also. So let's first. You can also share me the code so that I can take directly from your. If you have. Otherwise, okay, let me do it. So what we discuss, if stack 2 is empty, if that is empty, then what we are doing, if stack 2 is empty, take all the element from stack 1, put it into stack 2. So let's go through a loop until unless our stack 1 is not empty. Until our stack 1 is not empty, what we need to do, take the element from stack 1, keep pushing them into stack 2. So let's take the top element from stack 1 and let me put it into stack 2. Stack 2 dot push. Let me put it inside this. So that's it. We take the element from stack 1 and push it into stack 2. We need to keep deleting the top element from stack 1 also. Keep deleting whatever element you are pushing from stack 1 to stack 2. Keep deleting that also. That's it. So we will keep moving this loop again and again until our stack is not going to empty. S1 not going to empty. That's it. And after that, what you need to do after coming out of this loop, now you delete the top element because pop function is there. Pop want us to delete one element. Now we can delete the element from the top of the stack 2. So I'm storing this top element in stack 2 in a variable, maybe element variable I'm storing, and let me take the top element from stack 2. Stack 2 dot top. Stack 2 dot top. So taking the top element from the stack 2 and after that we can delete it. S2 dot pop, and after that we can return it. Return the element which we deleted, that we return. That's it. And one more condition, okay, you can write over here for the underflow. Okay, let me add it. If my stack 1 is also empty, if S1 is also empty, if S1 is also empty, then return -1, then return -1. That's it. So this is for the underflow. This is for the underflow. Otherwise, we just take all the element from stack 1 and put into stack 2 and then deleted the top element from stack 2. That's it. So pop is also done. Pop is also done. Fine, done. Now they mention one more function, that is peek. Peek function they are asking for, can you provide me the top element? They're asking me, can you provide me, which is the, okay, which is the front element actually, which is the front element, or you can say top element of, which is the front element, okay, or you can say top element of stack 2. Top element of stack 2. Q front element will be top element of stack 2. Understanding? What I'm trying to say is that pop function, okay, this is same as pop only. Okay, I'm repeating. Pop function is deleting the front element of the queue. This is the queue we are implementing. We are implementing queue, okay. And front element of the queue will be at the top of the S2. That will be at the top of the S2. We done it. We just delete this element. In the next function, in the peek function, they are not asking us to delete the element. This element they are not asking to delete. They are saying just return this element. Don't delete it, just return it. Don't delete this element. So okay, I will use the same code. Let me copy this code, because they're asking me to, they're asking us not to delete the element. The code is get replaced, I think. Oh shit. We need to write the pop function again. Okay, let me write it again. Okay, if S2 is empty, if S2 is empty, then we need to shift all the elements, need to shift until my stack 1 is not empty, until my S1 is not empty. We need to shift all the element from stack 2 dot top element we are taking, and we are inserting into stack 1 top element we are taking and inserting into stack 2 dot push So taking all the element from stack 1 and pushing in stack 2 and deleting the top element from stack 2. Wow. So this is what we already discussed. Okay. And after coming out of the loop, just I'm taking the top element from stack 2 int, taking in a variable. So I'm taking the top element s2 dot top. Fine. And after taking the top element, let me delete it, s2 dot pop, and after that, okay, return it, return this top element. That's it. And one condition also, I write for underflow, like if stack 1 is also empty, s1 is empty. So if s1 is also empty, then we will return -1 to show the underflow. Otherwise, just we take the element from stack 1 and put it into stack 2. That's it. This is what we have done, and return the element. So this is, we are popping the element. So let me copy this code. Same code will work for the finding peak element, but we will not delete the element. So let me remove this statement. So let me remove this statement. Let me remove this pop statement from here, and this is returning the top element. Okay, just we remove this statement and this will work fine. Okay, and last, one more function they have given. Actually, the 4 functions they have given in this. One is empty. They're asking, okay, if the stack is empty or not. For that, both the stack should be empty. Both the stack should be empty. So both the stack should be empty. So for, let me write the condition for that. Okay, we need to return, we will if S1 is empty, S1 is empty, and S2 is also empty. If both are empty, then we will return true. That's it. Now we can submit it. Let's see. Okay, where is the problem is coming? We will rectify that. So that is coming at 15 line code. So let me see my queue. Braces, some braces problem is coming. This is for this, and actually there was copy paste, then this problem occur. This is for this, this is for this, fine. This is for this, this is for this, this is for this, and is for this, this if is not ended. Okay, this if is not ended, let me end this. This if is not ended. So now let's submit it. Okay, one more braces problem I think here. Now this is here, and this is here, and this is here, where so all this happened in just a minute. So let me check out in my laptop. We inserted S1, fine. If you're finding, you can reply. Okay. So here this is fine. Here this loop is fine, and this is working here fine, and this is separate one, no problem. And this is if statement we done. This is the while loop, fine. This is the if statement, and this code this code will actually come out of the if. This code will come out of the if statement actually. So this will also come out of the if statement. So let's do it. Okay, we just put it inside the if actually. That should come out of the if. After coming out of the if, then we need to return the element. Okay. And let's see upside also. I think now it's fine. It should work now. Yeah, it's working now. So the problem was simply that, okay, I just put this code inside the if. So if the stack is S2 is empty, then okay, we are doing all that stuff. Otherwise, we were not doing any, we were not returning any element. Okay, but we need to return the element. So after coming out of this if statement, we need to put this code. So I put it. That's it. And the difference between the peak and pop is that in pop we are deleting the peak element. Here we are not deleting the peak element. They are just want to know what is the peak. So we just not delete it. Otherwise we do the same thing. Okay. Let's do one more thing over here. Count the bases once. I think we forget. Yes, what's working fine, Faizan. Great. But okay, any doubt in this, please ask. Otherwise, okay, let's do one more thing over here. Let me remove this this condition from here. Let me remove this condition. I hope this should work. We do not need to mention this underflow also. We do not need to mention this underflow because they have given some separate function for checking the empty. Okay, they have given a separate function to check the empty. Then we do not need to, I think, return from here. So let me remove this from here, and let's try to submit it. Okay, just doing some experiment. Yeah, it's working fine for this also. It's working fine. We do not need to check the underflow here in pop and in peak. Actually, they have given it here to check the underflow. If both stack are empty, then that is underflow. Okay. Any doubt in this, please ask. Any doubt, please ask. Anything coming to your mind, any doubt coming to your mind, please ask. Anything coming to your mind, anything you want to discuss. Top is front and peak in rear, sir. I am correct, sir? Okay. Divya is asking, peak and top are same thing. Peak and top are same thing. Okay. Peak, the meaning is peak and top are same thing. Means the top element, or you can say, okay, if you are talking in the term of Q, then this is the peak. If you are talking in the term of stack, then this is the peak. Okay. And in our program, actually, in our program, if you notice what we have done, by using the two stacks, by pushing all the elements from here to here, actually, now the elements were like this. So you can say that, okay, they ask us to print the peak element. Okay, the peak element is 10 in stack 2, and that is the same as which is the front in Q actually. Okay, so they are asking about the element which is going to be next deleted. Okay, in the Q, that you can say front, and in the stack that will be at the top. In the second stack that will be at the top. So this, they are asking about this element. They are asking about this element. Fine. Okay, fine. Now let's move to the Q part now. Any doubt in this, you can ask me. Anything coming to your mind, you can ask me. Okay, fine. Otherwise, let's move to the Q section. Q in C++ STL. So Q work on which principle? What is the principle on which Q work? Please write into the chat section. On which principle? Stack works on last in, first out. So on which principle Q works? Please write on which principle Q works. So that is also mentioned over here. That is first in, first out. The element which is inserted first, that will go out first. Okay, fine. So let's try to go through the Q in C++ STL. Q in C++ STL. So again, we will see how to declare it, what are the various functions, then we will solve a problem. Okay, fine. So let's go through. First of all, definition. Q is defined as the linear data structure which is open at both ends, and we can perform the operation in, first out. We can perform operation in, first out. Okay, first in, first out manner, we can perform the operation in the Q. The element which is inserted first, that will go out first. That's it. Now Q is uses DQ and list as the underlying container. DQ and list, because they are open at both end. DQ is also open at both end, and list is also open at both end. And this person is also, Q is also opened at both end. So this is helping to implement the Q easily. Okay, and we can perform the operation in constant time also with the help of DQ and list. List is actually, they are talking about doubly linked list. They are talking about doubly linked list. So this is internally they are using to implement the Q in C++ STL. So this can be an interview question. Okay, why DQ or list is preferred as the base container for implementing the Q in C++ STL? Why they are using DQ and list? Because they are opened at both end. DQ is also open at both end. Doubly linked list is also open at both end. And inserting in the DQ, this will take constant time, and deletion will also take constant time from the front. Same in the doubly linked list. So that's why these two data structures are preferred. That's it. Fine. Okay. This is the basics of the Q in basics of the queue in C++ STL. Now let's check out the syntax. Very easy. Just the keyword, queue is the keyword here. Then we will define the data type, which type of element this will store, this queue will store, and name of the variable, name of the queue, name of the queue. For example, we defined a queue. Queue is a data structure. Queue is a keyword. Sorry, queue is a keyword that we need to mention. Data type. This queue will store integers, and the name of the queue is Q1. And another example can be for like this queue is will store characters, and the name of the queue is Q1. For this one also we mentioned Q1. Fine. Okay, this is the syntax. Fine, easy. Let's see the functions. Let's see various functions. So this is also have the all just like same functions like push to insert the element, but here we insert at the end. We insert G element at the end of the queue. Constant time this will take. Another one is the pop. This will delete the element from the front. Pop will delete the element from the front. In the case of stack, these both were performing the operation at the top in stack. But here, push is performed at the end, pop is performed at the front. That's it. Both are taking constant time. Other operations. Okay, front. This will return the front element. Okay, let's implement them and then we will check out. If we will implement, then more clarity will come actually. So I'm going to the editor, going to the compiler, and let me make the space free over here. Fine. And okay, let's try to implement the various functions. You people please keep telling me what should be the output. Okay, so I'm declaring a queue. You know how to declare the queue, right? The keyword queue, its data type, what type of elements you are going to store, and name of the queue. Name of the queue is Q1. So we declare our a queue. That's it. Queue is created. Queue is created. That's it. And now let me push some element in this queue. So let me push Q1 dot push. Let me push some element. Let's suppose I push 10. One element. Let me push more element. Let me copy and paste this statement multiple times so that this can push many elements. So we push 3 elements. Okay, fine. 10, 20, and 30. Okay, we push 3 elements. Okay, if I see the size Q1 dot size, let me see the size of the queue. What will be the size of the queue? 3 elements we inserted, so 3 must be the size. So let me run it and let's verify. So we do not see out this, see out whatever is the size, just see out it. So we run it. So this is printing 3. Yes, 3 element we inserted 10, 20, 30, and we get 3 over here. Okay, one more function is there. There is a function front. Front function is there. Let me show you in the PPT. There is a front function which will give us the first element, which will return the first element. Okay, this will return the first element inside the queue. There is a back function which will return the last element, which will return the last element inside the queue. All are taking constant time. All are taking constant time. So let's implement these two now, front and back. Let me go to here, back. Let me try to print. Let me make some space, and let me try to print front and back. Okay, Q1 dot front element. Let me make some space and let me print the Q1 dot back. So just trying to use different functions. Okay, that's it. Can you tell me what will be the output? You please reply. Please tell me what should be the output for this code. Please keep replying. What should be the output for this code? Please reply. So please reply. What should be the output? So first is printing size, that is 3, and Faizan is saying then you will print the first element. So this is the Q. So when you are inserting the element will be inserted like this. First 10 will be inserted, then 20, then 30. So front is returning 10 and back is returning 30. That's it. Very easy. Very easy. Yes, let's execute and let's see if this is returning the right element or not. Yes, this is returning 3. 3 is the size, and first element is 10 and last element is 30. So just trying to go through the various function. Okay, let me apply the empty function also is there. So maybe I can print all the elements. So while Q1 is not empty, Q1 is empty. So until this is false, means there is some element inside the Q. Okay, there is element inside the Q. So what we can do, let me see out the front element Q1 dot front. So I'm printing the front element, and let me make some space also so that we can differentiate the elements. And we do not use the pop function. Let me write the pop also, Q1 dot pop. Okay, meanwhile let me remove this line. This line I have commented. So just check out this loop. Can you tell me, okay, what this loop will print? Now what this will print, can you tell me? Please tell me what this will print. So I just commented the above line. Just want to know, okay, how this loop is working. Do you know how this loop is working? Just want to verify if you know or not. Yes, Mandeep, you caught it. Yes, Mandeep, you caught the point. Yes, this will generate the error. This will generate the error. Why? Because pop do not return anything. Pop do not return anything. Yes. So if we will run it, this will generate the error. Okay, fine. So let's remove this. Now can you tell me what will be the output? Now can you tell me what will be the output? So we remove it. See out from the pop. So the order in which the element will come. Please reply. Keep replying. So we remove the cout. So the first we are deleting the front element 10, then 20, then 30. That's it. So 10, 20, 30 should be printed. Now 10, 20, 30. If we will write back, from the back the element will be what about if we write back? So this will keep printing from the back. Actually, this will print 30. Then pop the element from the front. Actually, print the element from the back. So this will not print all the element actually. Let's see. So let me run it. So this is printing, means back element is 30 only. So we are deleting from the front. We deleted 10, then we will deleted 20, then 30. But every time we printed the back element was 30 only, because we were popping from the front, and we can pop from the front only because this is a Q only. Okay, this is the Q. So these are the different operations. That's it. These are the only operation you need to know. These are the operation we discussed: push, pop, front, back, size, empty. All are taking constant time. This is important. All are taking constant time to execute. Now let's go for the exam. Let's apply the Q data structure to solve this very popular problem. asked in many companies, very popular again, implementing the stack using two queues. I take it from the again from the lead code, so you can check out this problem over there. But right now, can you give me the idea how you will implement the stack using two queues? Implementing stack using queue means you need to build this feature, last in first out. This thing you need to build up with the help of queue. Although queue behave like first in first out. Okay, first in first out, the queue behave like this, but you need to make them behave like this. If they start behaving like this, they will become a stack. They will become a stack. Okay, so what can be the idea? Any idea coming to your mind? You are given. Okay, let me write over here. You also keep helping me. Any idea coming to your mind, you can share that. Meanwhile, I'm writing something. So they are asking, they are saying that we need to implement a stack. So let's suppose this is our stack which we need to implement. This is our stack. So let me make it a little smaller. From here to here. Okay, fine. This is our stack. Yeah, Q is sufficient, Mandeep. That is more than enough. Now you can check out this thing. Let's solve this problem. That is sufficient. Number of functions are sufficient. No more functions are needed for the queue and stack. Done. You can solve all the problems on lead code and code forces. All the problems. Don't need any other function. Okay. There are some more functions. Very rarely they are used. Very rarely. I don't see any problem in which they are used actually. So I take all the important one which are most frequently used. Mandeep. Fine. Okay. So now let's implement the stack using queues. Let's implement the stack using queue. So we are provided with the stack. This is our stack. And we need to implement this stack using these two queues. First queue, Q1, and another queue, Q2. Q2. Okay. Let's suppose this is also actually easy. If you are inserting, you need to perform two operations. One is push and one is pop. So you please verify that, okay, if this idea will work or not. You please confirm at your end. This will work or not. I'm giving one idea from my side. If you have any idea, you can give from your side. So Fajan says that inserting is same. Fajan says that whenever the element is coming into the stack, let's suppose some element, let's insert. We insert, let's suppose 5 elements into stack. Just insert them into the Q1. 10, 20. Insertion is not making any problem actually. So whenever the element come, push it into stack 1. Push it into Q1. So just push the element into whatever element is that X, let's suppose. Push it into stack Q1. That's it. Push function done. Push function done. Now, if we want to delete the element, so according to stack, the element should be deleted 50. Element should be deleted 50. But here, because this is a queue, we cannot delete. We need to remove these elements first to delete 50. We want to make this queue behave like a stack. So we need to delete 50. For that, what we can do? We can take this element, put it here. Take this element, put it into the second queue. Take this element, put it inside the second queue. Take this element, put it inside the second queue. Now we can delete this element. Now we can delete this element. Okay. Now we can delete this element. Okay, I'm performing one more thing over here now. After deleting this element now, after deleting this element, I'm making this queue as a Q2. I'm changing their name. That's it. I'm saying now you are Q2 and now you are Q1. After deleting the element, why I'm doing this? Okay, we will see that. We will see that. But right now, let's see if this idea is working fine or not. Just see if what I'm talking is working fine or not. After that, why this is working, why this is doing, we will see that why also. But well, let's see first of all. What I do for deletion, for insertion, very easy. push, insert into the Q1, insert into the Q1. Okay. For delete, what you need to do, take out all the element, you can say n minus element, let me write over here, shift n minus 1 element from Q1 to Q2. Okay, this is what you need to do for pop. Okay, let's keep applying. Now let's keep insertion and deletion. You please ask me which operation you want to perform. Okay, first you tell me which operation you want me to perform now. Let's perform that. Push or pop. Please write in the chat box. First, that whatever will come, I will take that. Push or pop. Which you tell me operation. So we are implementing stack. Okay, we are implementing stack. So according to stack, next element that should be deleted is 40. So Divya says pop the element. So what pop says to us? Pop says that shift the n minus 1 element from Q1 to Q2. See, this is our Q1 now, and this is our Q2. Shift this element, and this element, n minus 1. Shift n minus 1 element from here to here. Okay, so let me erase this. This is actually empty. This is empty right now. Shift 10, 20, and 30. After shifting, we can delete it. After deleting, one more task you need to do. Now change their name. Make Q1 Q2, Q2 Q1. So now I make it Q2 back and make it Q1 back. Let me write here Q1. This is what we are doing, these two tasks while popping. Let's see if this is working fine or not. Then we will see why this is happening. Can you tell me, okay, if you will check out here, you can do any operation. Let me insert the element. Okay, now pop we have done. So let's insert the element. So inserting in Q1 always. So where is Q1 right now? Q1 is this. So let me insert element. It may be 50. So we insert more element 50 and 62 more element we inserted 50 and 60. If you will notice, the sequence is not changed. So whatever sequence we have inside the stack, 10, 20, 30, 40 we have deleted, okay. 10, 20, 30, 50 and 60. 40 we have deleted. So 10, 20, 30, 50 and 60. Yeah, sequence is same still. 10, 20, 30, 50 and 60. So we can push whatever element. If new element is coming 70, you can directly push in Q1. That is working fine. And whenever you need to delete, just shift n minus 1 element 10, 20, 30, 50, 60. N minus 1 element shifted and delete that element now. And after that, just change their name. Now, why we are changing the name actually? Why we are changing the name? This is actually helping us by changing the name. This is helping us. We do not, our push operation become very easy. Our push operation become very easy because now we are not worry about, okay, the sequence. Next element will come after this only. After 60 only the next element will come. Okay, the next element will come after 60 only, like 70, 80, whatever element will come, that will come after this only we are inserting. Okay, so this is helping us to implement it in easy way. And pop also only two functions we are performing. There can be many other method also. Okay, this is one method how we can implement the stack using 2Q. Let me tell you, actually this is the most efficient method to implement it stack using. Okay, Divya is asking, is there any other logic? Is there any other logic? Okay, is there any yes, there may be other logics also. Okay, let's talk about, okay, this here in this logic, if you can tell me, okay, you can fail it somehow, then you can tell me. Otherwise, okay, let's discuss other logic. So let me highlight the question of Divya. So here is the question. I got your logic, sir. Is there any other logic? So let's go to the other logic. Again, let's start. We need to implement this stack. This is our stack which we need to implement, and we are provided two queues for that. This will be little complicated. Okay, little complicated, but yes, this will also work. I'm sharing another method. You please verify this is working fine or not. We need to perform two operations. One is push, one is pop. So push operation, actually according to this second method, will be same. This will not increase the complexity. We need to just push into the q1 dot push whatever element we want to push, x, let's suppose. That's it, push is done. So if new element is coming 10, 20, 30, 40, then just simply insert them 10, 20, 30, 40. Just insert them in the same order. That's push function done. Second method we are covering, second way we are covering. Now I want to pop the element. Now this is little going to be complicated, because earlier I tell you the efficient approach itself. This will take more time, okay, but this is also logical, which I'm sharing right now. What we can do now, I want to delete the element. I want to delete this element. See, I want to delete this element. I will take this element here, this element here, this element here, just like previous one till now. And after that you deleted this, same previous one. After this, I just change the name in previous logic. Now, here I'm not changing the name, because that do not hitting to the brain actually directly. That logic is not hitting to the brain directly. Again, you need to think means over that, then only that logic will come to your mind. But this logic is more hitting to the mind in the first go. Now we are not swapping the names. Okay, that we are not swapping the name. We just shift this element, this element, this element here. Then we delete this element. Now new elements are coming. Okay, new elements are coming. Let's suppose 50 and 60. So 40 is gone. 40 we have deleted. 50 and 60, where you will store? So according to push, we are storing them here. 50 and 60. Fine. We are storing them here. Okay. If we are storing them here, see, this is the problem here. If we are storing them here, because this is saying that simply insert in Q1. Now, if we want to delete the element, according to stack, which element should be deleted? According to stack, which element should be deleted? That should be deleted 60. That should be deleted 60. So, but at the top of the Q2, we have 30. At the top of the Q2, we have 30. Okay, we have 30. We don't have 60. So this is one problem can come here, that okay, Q2 is not empty. One thing, okay, Q2 we can rectify it, but okay, fine. Q2 is not empty. So because Q2 is not empty, we are taking the element from here. We are taking the element from here, and this is not the top. Top is 60. Top is 60. So this can be one problem. Okay, let's suppose we are checking that, okay, if Q1 is empty or not, we can rectify the code. See, we are making the code little complicated now. What we are doing, we are shifting these element over here. We are shifting these element over here. Then we are deleting. Then we are deleting 60. Then we are deleting this element. Okay, then we are deleting this element. Before that, we are checking that, okay, if Q1 is empty or not. If Q1 is not empty, then we are taking this element, putting it here, taking this element, putting it here. Okay, and then we are deleting. Then, okay, let's suppose we deleted 60. Then we are deleting 60. Fine. Again, if we want to delete the next element, then we need to check, okay, if this is empty or not, and then we can delete from here. Now this time, see, earlier you were deleting the last element from here. Your code is getting complicated, means you are deleting earlier from here. Now you are deleting from here, top. If this is not, if this is empty, you are deleting from here. This is not empty, you may be deleting from here. Okay, or otherwise you are shifting here, then you are deleting. Fine, okay. Let me try to make it, take it other case in this. Can we make it fail further? Till now this is working fine, but okay, we need to add more condition in this, that okay, we need to check if the Q1 is empty or not. If Q1 is not empty, we need to shift the element, then we need to delete. Okay, fine. Let me try to make it to perform more operation over it. So let's suppose I inserted some more element here. Okay, and I want to delete the element. Then I will pop it here, and then we can delete. In the middle, let's suppose some more element come. Then we can again pop it here, and we can then delete the element. This is looking fine, but okay, right now this is looking fine, that okay, we need to shift the elements from here to here. This can be another idea. This can be another idea. Okay, fine, okay. Okay, I'm summarizing it. Mandeep, I'm summarizing this thing. What I'm saying is that, let me summarize the another way. Okay, I'm summarizing the other way. So this is our Q1, this is our Q2. Okay, so what we can do, push is same, just insert the element from whatever the way they are coming, push is same. But for deletion, when you are performing deletion, take this element here, take this element here, and then you can delete this element. Then you can delete this element. And in the middle, if element come, that can create the problem. You can solve it by shifting the element either here, either you can shift the element over here. Okay, if this is not empty, then shift the element over here, then you need to delete. Okay, either you can do this thing, or one more thing you can do. One more method you can use is that after deleting the element, after deleting this, shift back these three elements over here. So now you do not need to check, okay, if this stack is empty or not, because whatever element will come, like let's suppose 50 and 60 is coming, 50 and 60 is coming, then you can directly insert it here. They are in same sequence. Now if you want to delete, take this element from here, insert it here, and now delete 60. But you need to push them back here. 10, 20, 30, and 50. So that if new element is coming, that remains at the back of these elements. So this can be one another way. This can be one more another way. In the second method, in this method, in the third method, what I'm doing, push is same. We are pushing in the first queue. But for the pop, what we are doing, we are shifting element first here, deleting the element, and pushing back into stack 1. So this can be one another method. This one can be another method. Okay, so there can be other methods also, but these are little, what I want to say is that they are performing more operations. See, this is shifting n-1 element from here to here. Again, these n-1 element from here to here. So this is taking more time. As compared to our most efficient method. Asymptotically, all are taking n time. For push operation, but still okay, this is performing n2 time, shifting this element here and then n-1 element here to here. So 2n. Asymptotically, this method and most efficient is same, but that was taking order of n time, and this is taking 2n time. Okay. So yes, this is also another method, But the first one which I shared with you, that was the most efficient. Fine, okay. You can check out this. You can check out this yourself. Let's try to implement and finish it. Finish this. I'm going to the lead code now. Here is the problem. You can find out this problem. This is the same problem. Implement stack using queue, and here they provide us two queues, q1 and q2, and you need to implement four functions. One is push, one is pop. You need to tell the top element, which is the top element, and you need to check if the stack is empty or not. Again, the four push is very easy. So let's try to implement it. Push is very easy. In the push, we just need to insert the element inside the q1. So q1 dot push. What is the element? X. X is the element. So we will take this element and let me push it into q1. Done. Push is done. Push is done. That's it. Done. Okay, done. This is done. Push is done. Now let's do the pop. I'm implementing the efficient approach. What is the efficient approach? I will take n minus 1 element from q1 to q2. So let me write. First, in the pop, I will do two tasks. One is I will shift n minus 1 element from q1 to q2, and then I will change their name. I will change their name, so the new element will come. That will think that, okay, we do not need to shift the element back. Actually, we do not need to shift the element. We just change their name itself. So that is this is taking less time changing the name as compared to shifting the element back. So this is the two tasks we will perform in efficient approach. So let me first of all shift the element from q1 to q2, n minus 1 element. Yes, let me do it. So while q1 size is, I can say, okay, while q1 size is greater than 1, so until one element will be left in the q1, I will keep shifting all the elements from q1. So let me take front element from the q1, front element. So we are using front function, if you notice, because this is q, and we are putting this into the q2. So q2 dot push. So just we take front element from q1 and put it into q2. That's it. And then we need to delete also. Then we need to delete the element from q1 dot pop. Done. We shift, let me write, shift n minus 1 elements from q1 to q2. Done. This is the one task is done. Now, okay, let me delete the one element which was left. We shifted n minus 1 element. So one element which is left into q1, let's delete that. Let's delete that. So let me take that element into some variable. Let's suppose element variable. I'm taking the front element from the q1 front, so that I can return it, because I need to return something. So I store it into one variable. Now I can pop, I can delete it, I can pop this element. So q1 dot pop. Done. So what I done in these two statements, just delete the last element which was left. N minus 1 element are shifted. After that, the last element which we need to delete, we delete that. Fine. After that, okay, let me rename q1 with q2 and q2 with q1. Okay, so let me take a temporary variable of q type, same integer q type. Let me take a temporary variable in Q. Okay, and I'm storing Q1 in that and just swapping the number, and Q1 will be updated with Q2 and Q2 will be updated with temp. Just swapping the number, swapping the Q1 and Q2. Okay, swapping Q1 with the name of the Q1 with Q2. That's it, done. And after that, we just return this element. Let me return this also. Return the element. Done. Return the element. Done. So we're done with the pop. We just perform these two functions. Okay, you can say we deleted the element also, which was the nth element. After that, okay, we just rename and return this element which we deleted. Done. Okay, pop is done. And you know that top is the same, but we are not deleting the element. We are not deleting the element. We are just returning that element which is at the top. So I will copy this same code. Let me copy this same code and write in the top. And but I will not delete this element. Actually, I will shift this element to the Q2. I will say Q2 dot push. I will take the element from Q1 dot first, and I shift it to the Q2. Okay, I shifted it to Q2. I do not delete it. I do not delete this element because they are not asking to delete. They are just asking that, okay, what is the top element? The top element was the nth element, which I take in this variable. And I do not delete it. I put it all this also into the Q2. Okay. All the same operation done. I do not delete the element. I just take the element in a variable and put it into the Q2 back, and then we return it. Then we return the element. Fine. Okay. And for checking if, okay, for the empty, what we can check? We can check that, okay, if Q1 is empty or not, because we are always, we need to check only Q1. Q1 is empty or not. If Q1 is empty, we will return. We will return true. Return. Fine. Why we are not checking Q2? Because we are swapping them. Because we are swapping them. Okay. Every time actually Q2 will be empty always. There will be element into the Q1 only. Fine. Okay. So let me submit it. Let's see if there will be any problem. We will rectify that. So on 20th line, there is some issue is there. So let me check out that. While Q1 dot size is, okay, let me check out in my laptop. Okay, I do not put semicolon over here. That's it. And at 40th also I do the same thing. Don't put the semicolon, submit it. And at the 44, let's do the rectifications. 44, what is the problem? Keyword not first. Not actually first, that is front. Not actually first, that is front. Function is front. Front. Submit it. Again, let's check out. Oh, it's creating problem. Test case. Let me check out the logic. Okay, if this is creating the problem, where this is creating the problem. If you find it, you can reply it over. Okay. So here we are taking all the elements from the size until there that is not 1. Okay, and here we are popping the element. Maybe that is happening due to underflow. So let me check if that should not be the problem actually. Underflow. So q1 dot size is, if until that is greater than 1, we are just taking the front element from q1 and pushing it q2 and taking the element from q1 out. Fine. And we are taking the front element and we are popping that element. Fine. And we are then swapping the numbers, swapping q1 with q2. Fine. That's the problem. Then we are returning the element. And here we are this is the same code will be there actually, just one line will be different because we are taking the front, we are not deleting the element. Are we deleting the element? We need to, I think we need to delete this element because still the element is there. Yes, I think we need to delete this. Yes, so we need to delete this element because the element is in q1, okay, and we shifted that into q2. Yes, we need to delete the element also. We need to delete the element because we shifted that, but there should not be no element in q1. Yes, I think this should be the problem. So let me submit it and let's see once again. Yeah, this is the problem actually. Yes, this was the problem. Problem was, okay, let me check out. The problem is that, okay, we need to delete the element also here because we shifted the element, but still the element is present, last element is present into the q1. That should not be there because we shifted that into q2. So that should not be there. Yes, this statement will also come. We need to delete that element. Yes. After that, everything is same. Just we what we have done, we just not deleted it, but we copy also. So in this new statement we added, if we compare it with the pop operation, this new statement we added, before deleting it we copy it, while in the pop we do not copy it, but here we copy it. Okay, so this was the problem. Okay, here. Okay, Divya, do you get it or do I need to explain it? So okay, I'm going it once again throughout the code, once again complete code before winding up it. So we just taking two queues and let me take my keyboard here. Let me take my mouse here. So we just push is very easy. We know that we just inserted the element q1. This is done. Push is done. After that, in pop, we take n minus 1 elements from q1 to q2. q1 to q2. And the nth element we deleted. Here we deleted the nth element because we are popping. Okay, we will delete the nth element. And after that we rename. After that we rename the q1 and q2. Fine. We rename the q1 and q2. Fine. We rename the q1 and q, and we whatever element we deleted, we return the element. Fine. Okay. This is the pop function. And if we come to the top function, this will not delete the element. This will return that element. The top element will not be deleted but will return. So just one statement we need to add over here. We will, before deleting that element, we will copy that into stack 2. So we are not actually, we want access of that element because we need to return this. So we take that element in a variable and copy it into stack 2 because we don't want to delete, because they don't ask to delete, they ask to return the element. So we just copy the element into our q2. Then okay, we delete that element because we already copy that element. So we do not delete, we do not need to delete, we just need to return. So we store it into a variable and copy it into q2 because we don't want to delete it. And okay, then we can delete because we already copy. So this is the only difference, one line difference between this pop code and top top code. Okay, I hope that is clear. And empty, just check the q1, because if the element will be there, then that will be into q1 only, because every time we are swapping the name, whoever is having the element there, that is q1, so that's it for this. Okay, fine. uh, Let me go back to my ppt. So that's it actually for today's session. So today we covered stack and queue. We check out how to declare the stack and queue in C++ STL. This thing we learn how to declare them, what are the various functions related to that, what are their complexity. We check out the complexity of these functions. All were constant today. Today all the time complexity of all the stack functions and all the queue functions were constant only. And after that, we solve one problem from stack and one problem from queue, from the MAANG company. So we apply those stack and queue and their functions in these two problems. So I hope you learn from this session. You now actually nothing is left into the stack and queue. So this is the only concept which will be repeated in all the problems if you are using stack and queue. Okay, we will use these inbuilt data structure, but to solve other problems, same functions will be used. Now you will not face the problem. Okay, the motive of these classes is that to make you familiarize with the structure of inbuilt functions. Okay, like stack and queue functions, inbuilt functions, and they have their own functions like push pop. Directly we can push pop the element, check the empty or not, check out the top element, check out their size. So you can use these functions with them. And I hope you get the idea how to use the inbuilt stack. That's it for today. If you like this session, if you learn from this, please give a thumbs up and write in the comment section. And good night. We will meet tomorrow. I'm ending this session now. Thank you. I'm ending this session.